the trig identities that would be on the back of your circle. And these would go at the back on the top. I wouldn't put them on my purple sheet yet. I'd put them on my notes and then transfer them to my purple sheet when I can do them in an organized manner. The purple sheet, hopefully, is going to be really nice and neat when you're finished. But here we go. The first rule is, I was going to put x squared plus y squared equals 1, but that's not the trig identity. Trig identity, the very first one we want to talk about is that cosine squared theta plus sine squared theta equals 1. That's the mother identity. And some books call it the Pythagorean identity. They call it the Pythagorean identity. And I don't know if you really need to write that in your notes, I mean, when you put it on the purple circle or not. But it's called the Pythagorean identity because we know x squared plus y squared equals the what? Hypotenuse squared, and we know that the cosine of theta is the x and the sine of theta is the y. Now, the identities that go with it, and the reason I call that the mother identity, is that cosine squared of theta equals 1 minus sine squared of theta. All I did was algebraically rewrite that one. See how if you know that one, you instantly know this one. Is that cool?
Or putting this on the back where you insert.
But not today. You're going to do that after you take notes on it, but you got to take notes on it to be able to put it on the back, right?
Or you know, putting that on the back.
Yeah, but not today. I would put it in my notes and then transfer it when you get in order. Because when you put it on your purple circle, you want it to be really pretty, really in order. Now, and I'll probably get one or two of them out of order. And then I bet you already know that sine squared theta is equal to 1 minus cosine squared theta. And those are your three identities. They're called your Pythagorean identities. This is your mother identity, and these you rewrite. Now, if I were putting it on the back of the purple page, I would probably do these major ones in one color and then do the rewrites of it in another color. Or I would put this one and then I might indent these two. What I'm getting at is, if you happen to memorize them or learn them, if you learn this one, you can come up with these two, right? Is that okay? Does that make sense? All right. I'm going to put two more under here, but I'm going to show you how to get them. All right. Cosine squared theta plus sine squared theta equals 1. And what I'm going to do is I'm going to multiply both sides of this. Multiply by 1 over cosine squared theta. I'm going to multiply both sides by 1 over cosine squared theta. You know, whatever I'm going to do with one side, I have to do to the other. So if I multiply here, 1 over cosine squared, I'll get cosine squared theta over cosine squared theta plus sine squared theta over cosine squared theta equals 1 over cosine squared theta. So I took the mother identity, and I just multiplied the mother identity by 1 over cosine squared theta. When I do that, what does this equal? 1. What does sine over cosine equal? You know this. What does sine over cosine equal? Talked about it in geometry. Tangent, yeah. Tangent of theta is equal. Okay, you might need to put that on the back of your circle or on your circle. Tangent of theta is equal to sine theta over cosine theta. Put that on your front of your circle because you know that. Tangent of theta is equal to what? Sine over cosine. All right? So that equals tangent squared theta. And do you know what 1 over cosine equals? Now that we did talk about the other day and stress it. What does 1 over cosine equal off the front of your circle? Secant. So that's secant squared. That is another trig law. So on the back of your circle, you're going to write that one. 1 plus tangent squared theta equals secant squared theta. And somebody says, Mr. Evans, that's not what's in the book. In the book it says tangent squared theta equals secant squared theta minus 1. All right? See how you could rewrite that if you wanted to? Or you could say tangent squared theta minus secant squared theta, or secant squared theta minus tangent squared theta would equal what? 1. But you could rewrite this a lot of different ways, but you know you can do that algebraically. That's what we got to have. And I showed you how to help you memorize it, because if you have the mother identity, you just multiply everything by what? 1 over cosine squared. Are you noticing how you can do algebra with these trig functions? All right, yeah, that's what I'm hoping you notice. Now, let's do it again. Let's take cosine squared theta plus sine squared theta equals 1. And let's multiply that by 1 over sine squared. Well, I'll get cosine squared theta over sine squared theta plus 1 equals 1 over sine squared theta. Oh, I bet that, you can already tell me what that reduces to. If tangent is sine over cosine, what is cosine over sine? Cotangent. Tangent is sine over cosine, and the reciprocal of tangent is what? Cotangent. Cosine over sine. So we're going to get cotangent squared theta plus 1 again, because that's going to be what? Sine squared over sine squared. And then what is 1 over sine equal? Cosecant. And since we got squared, it'll be what? Cosecant squared. And there's your cotangent rule. So the first 4 rules really all come from cosine squared theta plus sine squared theta equals 1. That's what the first rules come from. All right? So, that's good news. So if you memorize the first one, and you had to, you can come up with these 2 rules. And I'll be honest, folks, Mr. Evans is not good at memorizing the rules. So in my brain, I'll be trying to remember what tangent squared rule is, and I'll go, okay, divide by cosine squared. 1 plus tangent squared equals secant squared. All right? And it just fits. It works in your brain. All right, that's how you get the rules. So this part wouldn't go on the back of your unit circle. This would go in your notes. That list of 5 over there would go where? On the back of your unit circle. Good deal so far? All right, now, the next few that I want to show you are I'll use that space too. These rules, I can't show you why they work. All right? I don't even know if I could prove it. If you said, Mr. Evans, you've got to prove why these rules work. I might could prove it if I started working with them, but I probably couldn't. Okay? Here's rule. These are called sum and difference rules. Okay? These are called your sum and difference rules. If you want to know what they're called, identities. And here you go. All right, and they're kind of long, so I hope I can fit them in there. The sum. Okay, we have the sine of alpha plus beta. Beta is just a B with a little tail on the end. The alpha is a little fish. You can use A and B if you want to. High school textbooks use A and B. Your college textbooks use A and B or alpha and beta. I just get you used to seeing alphas and little betas. Okay, plus I can make those. That equals the sine of alpha cosine of beta plus the sine of beta cosine of alpha. That's what the sine of alpha plus beta equals. And this is one you memorize. All right? That's what it equals. Now, I'm going to work a problem and actually show you where we could use this. Okay? Show you where you could use this. I want to know the sine of 75 degrees. And it's not on my unit circle. And I want to know the exact value of the sine of 75 degrees. I want to know the exact value. I do not want a 4 decimal place approximation out of your calculator. I want to know the exact value. And it would say that. Find the exact value of 75 degrees. Or somewhere in a problem in calculus, you need to know the sine of 75 degrees. And actually, you probably wouldn't have to because we usually use things around the unit circle. But I'm going to show you how to get that exact value for sine of 75. Sine 45 degrees plus 30 degrees. Because 45 plus 30 is what? 75. Is that okay? Pretty cool. This is your alpha plus your what? Your beta. So the sine of alpha plus beta equals what? The sine of the alpha cosine of the beta plus sine of the beta cosine of the alpha. Now, if you want to write it in a different order and be wrong, that's fine with me. You write it exactly like this. You don't write it any other way. You write it exactly like this. Okay? No other way. Now, you look on your unit circle. What is the sine of 45 degrees? Look. What's the sine of 45 degrees?
1 over square root of 2.
What's the cosine of 30 degrees? Plus, what's the sine of 30 degrees? What's the cosine of 45 degrees?
1 over square root of 2.
Now, here's the good news. If you're doing this right, you'll always get a common denominator. It'll always work out where you have your common denominator. Square root of 3 plus 1 over 2 times square root of 2. Now, I would leave it just like that. But what do you think the textbook does? It multiplies the numerator and denominator by what? Square root of 2. It rationalizes it. Everyone okay with the idea that it rationalizes it? Is that okay? But we're just going to stop right there. If you try to get the answer in the back of the book, it's rationalized. But here's what's awesome. Notice how you get a common denominator. These students always look at these going, oh man, I got fractions. But I can tell you, if you do it right, you're almost always going to have the common denominator there waiting on you. And that's one of the ways that this rule is used. It's used for something else too. This is one of the ones that you have to know the second week of calculus, right here. In the BC class next year, we will use this rule the second week of calculus. Matter of fact, we'll use the sum rules a lot. We don't use the difference rules very much at all. Okay? But you'll need this one the second week of calculus. Or third week if you need. Now, let's do sine of alpha minus beta. And that would equal sine of alpha cosine of beta minus sine of beta cosine of alpha. And that one's a pretty easy one. You know, you just change the sign and do it. It's not hard. I could give you an example of this one if you wanted to know what the sine of 15 degrees is. Because that would be what? 45 minus 30, right? So anything, any angle that's a pairing of what you've already got on your unit circle, you could figure out by doing this. And then, of course, you could use 75 and 30 to find out what 105 is. See what I'm getting at there? Because once you knew what a 75 was, if you added 75 and 30, you'd get 105. So you could take this one, use it for your 75, and keep working. Is everybody? I'm seeing some blast over eyes. I'm seeing some people going, yeah, I understand what you mean. In other words, once you knew this number, you could use it to find more. All right? Okay, now, and there's sine. Let's do the cosine one. The cosine of alpha plus beta is equal to the cosine of alpha, cosine of beta, minus the sine of alpha, sine of beta. All right? And yes, if that's a plus sign there, that is a minus sign there. People miss that one all the time, so they think you just have to do it this sign. All right? And you could have the example for that would apply to this. If you want to know the cosine of 75, 45 plus 30, put them into that formula, and you're on your way. Cosine of alpha minus beta is equal to cosine alpha, cosine beta, plus sine alpha, sine beta. And that's the only form Mr. Evans knows. Since we're going to be putting them on your page, I'm going to talk to you about two more, but I never learned those, and I'll show you why. Put two more on there, but I really never learned these other two. Still don't know them today. I'm going to have to look it up in the book. Might be able to figure them out. Matter of fact, we might do that. We might see if we can figure them out. Then again, we may not. All right. Here we go. Tangent of alpha plus beta. Okay, I'm going to show you how I do it. Okay. I do not memorize well. If I do not memorize well, but I have to memorize those four. I can't get by without those four. What I do is I just do sine alpha plus beta over cosine alpha plus beta. And then I just do what? Use that rule over what? That rule. Is that okay? And that's how I would do it, because I didn't memorize the rules. But there's a better way, because there's a short rule if you memorize. But if you can't memorize them, just remember, as long as you know those four, you can do anything else. Okay? But I'll tell you the other rule. What the other rule is, and you notice I'm going over here to the book, and I'm going to see if I can find it here. Sums and differences. And let me see if I can find the tangent rule here. Because there's a short tangent rule, but if you know it, you don't have to do the long way that I just suggested. Wow. Yeah, I should be able to prove that one. I probably could if I really wanted to. I'm going to find, do some more. But here's what tangent of A plus B equals. Here's what you do if you want to just know the rule. Okay, equals tangent alpha plus tangent beta over 1 minus tangent alpha tangent beta. Hey folks, by the time I memorize that, I might be better off just doing what I suggested. Okay? I think what I'm suggesting, doing it this way, may be better than knowing that. So you might want to put tangent alpha plus beta equals that if you want to know the rules to the textbook. Or tangent of alpha plus beta equals this, and then just go back and do what? Those four rules. Well, you get the same answer either way. I didn't realize it was that complicated that what tangent alpha plus beta equals. I would do it the way I suggested. I'd just go ahead and use that. All right. And then, of course, there has to be a tangent alpha minus beta rule, which if I was doing that, I'd do sine alpha minus beta over cosine alpha minus beta. I wouldn't memorize these tangent rules, but since you're going to have your unit circle carried with you, we'll put them on the unit circle. But you might want to put a little hint that there's another way to do them. Oh, I'm sure guessing on this one. I better look at the book. Yep, and then that comes one plus. That to me doesn't look any easier than doing what I suggested. Tangent alpha plus beta equals sine alpha plus beta over cosine alpha plus beta. Okay, that's how I'd work it. I'd do this, and then I'd just pick that formula over there. And you could also do one for tangent of alpha minus beta. Write it under there. Do I need to write it under there, or can y'all write it under there? All right. So I'd go ahead and put all four of those down with those four. And that gets you through the sines, alpha plus beta, and all that good stuff. Now, that's a lot of work just to get to those. And those, okay, so there's your sum and difference identities that we're going to use this year. Okay. Yes, sir.
For the tangent alpha minus beta, we put sine alpha minus beta.
That's right. That's what you would do. Yes, sir. See, and that way you don't have to try to remember. Here's the problem. Some of y'all are great at memorizing. Then you memorize a lot of rules. Some of you are like me, and you don't memorize a lot of stuff well, so you have to know how to adapt. And the way to adapt is to make sure you memorize those four, and then you can just work these out this way. That's the advantage there. Okay? Now, and those are called your sum and difference rules. Yeah, let's go ahead and get those out of the way too. I'm going to go ahead and give you a few more to put on there, even though we don't need them yet. These we're going to use pretty soon. We'll go back and use these. Notice we've already used these with the unit circle, right? Okay. Gave you an example how to use all those. These are called the double angle identities. Double angle. Actually, using the name they call these by. Double angle. Good. Angle. I just did angel. Angle. Let's go with that. Angle and angel. Let's try to spell phonics. Okay, the double angle identities. The sine of 2 alpha or 2 theta, we'll use a little theta there just to change it up, is equal to 2 sine theta cosine theta. In other words, the sine of 2 times some angle is equal to 2 times the sine of whatever that angle is times the cosine of whatever that angle is. Cool? All right? And that only has one angle involved. You can put alphas there if you want. You can put betas there if you want. Doesn't matter. You can put x's. The cosine of 2 theta is equal to cosine squared theta minus sine squared theta. Now here's the problem. That's the only one of the cosine 2 thetas I remember. If you remember that one, you don't need to know these other two because you can always get them. This one, I think this is the one that I use most of the time, but I'm going to give you the other two since you're going to have them on your sheet of paper. cosine 2 theta is equal to 1 minus 2 sine squared theta. How do y'all think I did that? Remember the one I did earlier today where I knew that cosine squared was equal to 1 minus sine squared? I just turned that cosine squared into what? 1 minus sine squared. When I make it 1 minus sine squared, 1 minus sine squared minus another sine squared is 1 minus 2 sine squared. So I use the mother identities, little children, and I put it in there. And that's another way to write this one. And then cosine 2 theta, you make that 1 minus cosine squared, so you get 2 cosine squared theta minus 1. And all you've done there is